Here is another example. In this example, there are two transistors connected. One of the base of the transistor connected to collector of the second transistor. So I'm going to take this as T1 and T2. Probably our goal is going to be what is the VC value and what is the current passing through this. So I'm going to call this as IE and that must be IC. Since it's a second transistor, I'm going to label them as 2, IC2, IE2, something like that. So now I think we solved the similar case in the previous example. So all we need to do is convert this into a single source, single resistor. I'm going to use the Thevenin theorem. So the circuit is going to be simply something like this. That's a 15 volt. I'm just redrawing this circuit. So it's going to be, so I'm looking the circuit from VB and the ground point of view. So that is the reason the circuit is going to look like this. Okay, that's 50k. So this is what our VB is going to be, or VBB basically. Our VBB is 15 times. I'm going to use the voltage division rule. This is VBB. 15 times 50k divided by 150k. So that's going to be 5 volts. Now you need to find the RBB resistance connected to the base. So while finding that, remove all the voltage sources with the open short circuit, current sources with short circuit. So we have 100k parallel with 50k. So your RBB equal to 100k parallel with 50k will end up with 33k ohm resistor. Now I'm going to redraw the circuit. I'm going to draw only T1 and I'm going to assume that transistor is in active mode and solve for the parameters. So here is the circuit of T1, transistor 1. I'm going to assume this transistor is working in active mode of operation. So I'm going to apply the loop equation right there. So this is my base and emitter. How do I know this is emitter? The arrow is on the emitter always. So since I'm assuming active mode of operation, VB equal to 0.7 volts. So I'm going to write down the KVL equation. -5 plus 33.33k. It is 33.33k. I forgot to put 0.33 there. So it's 33.33k ohm. So -5 plus 33.33k IB. The current passing through this must be IB plus 0.7 plus 2k times IE equal to 0. Now did he give us the beta value? He didn't. He's supposed to give the beta value. I'm going to assume beta value as 100. Okay, if I do not give you beta value in the class, please assume that value as around 100. So based on the beta, I can tell alpha equal to 0.99 beta because alpha is beta over beta plus 1. Okay, now same thing, I'm going to replace IB with IB equal to IC over beta and IE equal to IC over alpha. So here I solve the example. So here is the equation from this loop. Okay, -5 plus 33.33k times IB plus 0.7 plus 2k times IE. The current passing through this is IE. We know that IB equal to IC over beta, IE equal to IC over alpha. Beta value is 100, so alpha value should be 0.99. So based on that, I found IC equal to 1.82 milliampere. Once I know IC, I found IE, and then I found the VC, VE. So based on that, I found the VCE is greater than 0.3 volts. As long as we found that value, then this transistor must be in active mode of operation. Now we're going to start solving the second transistor. So all I know, the voltage at this point, VC equal to 11.4. So all I know, the voltage at this point is 11.4 volt. So based on that, we'll find out the second transistor, what's going on with the second transistor. Here is the second transistor circuit. Now from the first transistor I found VC is 11.4 volts. So from the transistor 1 we can see this is the VC1, that VC is same as the VB2 base voltage of the second transistor. So based on that I found that, I took that voltage as 11.4. Now I'm going to assume active mode of operation. So if that is active mode of operation, I know this voltage must be 0.7 volts. This is VB, that's VE. So what is the VE value? VE must be VB minus 0.7. So that must be 10.7 volt. Once I know the VE, I can find IE. IE equal to VE over 3K. So based on that, I found this current as 3.56 milliampere. Once I know IE, beta value here also, I'm going to take that as 100. Most probably the author needs to give you that value. Since he didn't give us, I'm taking that value as 100. That value is in between 50 and 200. Now based on that, if I know beta, alpha equal to beta over beta plus 1, so it must be 0.99. So based on that, I can take IC equal to IE times 0.999, because alpha is nothing but IC over IE. So I'm finding IC value, so 3.566 times 0.99, that will give me 3.531 milliampere. Okay. Based on that, I can find VC. So VC must be 15 volt minus 1K times 3.531 volt. Sorry, 3.531 milliampere. So it must be 15 minus 3.53, that value 11.47 volt. So I know VC and VE. So VCE must be VC minus VE. So VC is 11.47 minus VE is 10.7. So definitely this value is greater than 0.3 volt. So definitely this is an active mode of operation. Now we found the VC2 second transistor by assuming the voltage at VB is 11.4 volt. In reality, is that the 11.4 volt? It might not be true, because the reason behind it is, if you remember, here we took the current IC, the current going into this transistor, that's called IC1. Okay, but I took this current as IC1. Reality, it's not IC1 because there must be some current passing through this. So what I'm going to do to make it more accurate, I'm going to take more accurate value of this current IC. So that way I can find the voltage here a different value. So we call that as second iteration. So I'm going to do the second iteration. So to find the second iteration, I need to have the IB2 value. First let me find IB2. So here I'm trying to do the second iteration. So in the second iteration, in previous case, I took the IB2 as 0 milliamperes. Now I found that it's not 0, the value is 0.0356. And I found IC1 as 1.2 milliampere. So based on these two currents, I can find the current supplied by, our current passing through this must be this current minus this, that will give you the current passing through this 2 kilo ohm resistor. I found that, and I found the VC1 as 11.43 volts. Previous case, how much was it? I think it was like 11.4 volt. It's not much difference. I'm pretty much sure the values are not going to be too big difference. So most probably you're going to end up your IB2 is the same and your VC is almost same, VC is going to be almost same. So I'm not going to go for the second iteration. I'm not going to complete the second iteration. If there is a big difference, like if this voltage changed from 11.4 to like 12 volts or 10 volts, then I would have continued, but the difference is not too big, so I'm going to stop the second iteration here. Okay, thank you guys. In the next video, most probably I'm going to start doing the AC analysis. Thank you.